All right, here is the lesson on random variables, and you should be doing this pair deck that's on Schoology. So we're going to use random variables to look at how health insurance works. And a prompt I would discuss if I was there is, should everyone buy health insurance? Why or why not? Next class, we're going to do the D quiz tube on box plots, percentiles, and transforming. And that was moved to Tuesday because I have a sub today. Class after next is the D exam. And then, so finish a review on WebAssign. It's a quiz grade. And then the E1 reflection will be open for full credit through 12/12. To get late credit on D1 through D4 reflections, please request an automatic extension. And if you see Grant or Bella, wish them a happy birthday. So, we're going to go ahead and look at insurance. Assume that Alonso, Beatrice, Claire, and Daniel are the only citizens in a tiny country of 4. Now imagine that the only medical procedure ever needed is a $40,000 heart surgery. Our first resident is Alonso. He has a 1% chance of needing the surgery. What is the expected value of health insurance for him? So the probability that he needs surgery is 0.01, right? So we put that in there. And that means, and we know the probability model has to add up to 1, so this must be 0.99. If the probabilities add up to 1, our model is valid. Then we calculate expected value by taking the outcome and we multiply it by its probability. It's kind of like those weighted averages we were doing in the lesson in the last unit. So 40,000 times 0.01 is $400. $0 times 0.99 is $0. So the expected value is going to be the sum of all these products, which is $400. Our second resident is Beatriz. She has a 16% chance. Oh, and the expected payout is $400. So we expect him to need $400 in a given year for heart surgery because that's his probability is so low. Our second resident is Beatriz. She has a 16% chance of needing surgery. And so we're going to calculate her expected value. We put the 0.16 there, the 0.84. Remember, these need to add up to 1. And then we just multiply them out. And we get an expected value of $6,400. So that is the expected value of her insurance. We have another resident, which is Claire. She has a 25% chance of needing the surgery. So now I'm going to put 0.25 right there, 0.75, multiply across, and add. And so the expected value is 10,000 there. And now we have Daniel, who apparently does not have a good heart. There's a 50% chance he needs the surgery, 50% that he doesn't. Multiply across. So the expected value for his insurance, how much he'll have to pay out, is $20,000. So the expected cost of all 4 of our residents, we have $400 for Alonso, $6,400 for Beatriz, $10,000 for Claire, and $20,000 for Daniel. It's $36,800. And then we can calculate the average cost by dividing by the 4 residents. So we should charge about $9,200 for this insurance. So imagine the country charges everyone the same price for insurance. If the company only needs to break even to earn as much as it spends, calculate how much it should charge. At this price, who will buy insurance and will the company expect to break even? So anyone whose expected value is less than $9,200 won't buy insurance. For example, Alonso really doesn't expect to have to pay for a big surgery, so he's not going to pay $9,200 when for him the value of it is only $400. Beatriz is at a higher expected value, but it's still lower than the $9,200. So year 1, the price is $9,200. Claire and Daniel will buy it, but Alonso and Beatriz will not. So now let's go ahead and calculate for year 2 what is the expected value of insurance. So the price for year 2, we have $10,000 for Claire and $20,000 for Daniel. Remember, those are the expected values on the previous slide. Remember that? So let me scoot back. See, there's your 10,000, there's your 20. All right, so we'll come back here. So on average, we expect $15,000 because we only have Claire and Daniel in it now. But at $15,000, Claire goes, whoa, I only expect to pay 10. Why should I pay 15 for insurance? So Daniel's the only one buying it and no one else is. And then finally, price year 3 is Daniel. He'll probably go ahead and buy it because it breaks out to what he's going to do. And at least it covers it in case he does have a $40,000 insurance. Now, the people who won't buy it will be A, B, and C. Now, to keep prices low, some people believe that companies should be allowed to deny insurance to high-risk people. If the company refuses to cover Daniel, what will happen in years 1 through 3, and is this a good solution? So we get rid of Daniel's cost, which was $20,000 a year. So we have $400 for Alonso, $6,400 for Beatriz, and $10,000 for Claire. So we'll charge $5,600 in insurance, and both Beatriz and Claire will think that's a good buy, but Alonso's like, no way, Jose, and he doesn't buy it. So now we're only left with 2 people buying insurance, so we're going to take their expected values and average them. We should charge $8,200. Well, who's going to buy it? Claire is, but not Beatriz, and so that means our value is going to go up again to $10,000, and so the only person buying insurance is Claire, and Alonso and Beatriz are not. So, continuing the scenario above, imagine Beatriz has a heart attack at the end of year 3. Even though she is uninsured and can't afford the surgery, the hospital saves her life, but it increases the price of surgery to $50,000. How much will insurance cost in year 4? And is this fair to Claire? Why or why not? So now for Claire, she has a 25% expected cost, probability, right, of paying $50,000. That's $12,500. Claire will buy this because this is her new expected value, so it's worth it. It's not fair to Claire because she's the only one paying out, but others are benefiting from it. So, when a hospital treats a patient without insurance, it makes insurance more expensive for everyone else. To prevent this from happening, some people believe insurance should be required to cover everyone and that everyone should be required to buy insurance. If everyone has to buy insurance, what will happen in years 1 to 3? So year 1, we have $9,200, but everyone's required to buy it. Nobody's not buying it. And then again in year 2, so we kind of stay stable. So that was where a lot of people were saying, hey, let's make people have insurance. For example, when you're driving, you actually have to have driver's insurance. It's not legal not to. All right. In reality, countries have more than 4 people, so this makes it a little easier. Our health costs are still not super low, but there's more low-risk people than there are high-risk ones. So if 70% of the population is like Alonso, 20% is like Beatriz, 9% is like Claire, and 1% is like Daniel, we can look at the payouts and their associated probabilities. So 400 times 0.7 is 280, 6,400 times 0.2 is 1280, 10,000 times 0.09 is 900, and then 20,000 times 0.01 is 200. So you can see actually expected payout, the contribution from Daniel is one of the lowest ones that we see, just because it's a very low percentage of the population. And so our insurance, our total cost, when we add all these up, is $2,660. So why is this a good solution to require health insurance coverage? It stabilizes and minimizes prices. Now for you guys, there's a big con, right? Young people who are poor and healthier must subsidize the health cost of those who are sicker. All right, we'll do some practice now with some more expected values, and we're going to look at a different example. X is the number of surgeries covered. So the insurance company has sold 100 policies and determined that the probabilities of the numbers of surgeries they will have to cover that year. They do not expect more than 4 patients to need surgeries. What is the probability they don't have to cover any surgeries? So you can see I have the answer there. It's 0.66. How did I get that? Well, I added all the other probabilities right here, and I subtracted that value from 1, and that's what gave me 0.66. What is the probability they have to cover at least 2 surgeries? So this 2, 3, and 4 all count as at least 2. Probably the hardest part about this unit is understanding at least, at most, more than, making sure you have the right values of x. So at least 2 means 2, 3, or 4. X is 2 or 3 or 4. And we add up those probabilities and we get 0.14. What's the probability they have to cover at most 2 surgeries? Well, that would be 0, 1, and 2. And we add up the associated probabilities, 0.66, 0.20, 0.10, and 0.96. Now, the insurance company has sold 100 policies and determined that the probabilities of the number of expected surgeries they will have to cover that year, they do not, I'm still in the same problem. Now, how do we calculate expected value and standard deviation for the number of surgeries they must cover? Well, expected value, I would still do the 0 times 0.66, the 1 times 0.20, the 2 times 0.10, the 3 times 0.03, and the 4 times 0.01. But that's a little tedious, and we do have technology like Staplet, and I'll show it to you in a sec. So with the Staplet, we found that the mean or expected value is 0.53. Remember, mean, expected value, and average are all the same value. And we have a standard deviation of 0.866 surgeries. And the way we interpret it is we expect the number of surgeries for each 100 policies to vary by about 0.866 surgeries, about the mean of 0.53 surgeries. So I will go ahead now and show you how to use the Staplet. So when you go to Staplet, we're going to that same applet, discrete random variables that we went into in the last unit. I'm going to have to add a couple of rows. And we're doing number of surgeries covered. And my first value is 0. Probability is 0.66. Then my next value is 1 surgery, 0.20, 2 surgeries, 0.10, 3 surgeries, 0.03, and 4 surgeries, 0.01. Now, if I had made a mistake and I had put 0.02 by accident, say, oh, you got a mistake there. These all have to add up exactly to 1 for this to work. Okay, and then once you're done, you can see, here, let me kind of scroll that up. You can see there are the summary statistics. I can probably zoom that out just a little bit. And there's your mean of 0.53 and your standard deviation, and there's your distribution. So pretty straightforward in Staplet. Just make sure you do discrete random variables, put in the values for each one and the associated probabilities.